2 series pumps are precision made and have extremely close running tolerances. Take care when cleaning and handling the fluid head, which includes the cover, body, rotors, and seals. Catching wear early is important to reducing your maintenance costs. Periodic checking of lubrication, noise, vibration, and bearing temperatures are recommended, as well as a simple look-feel inspection of your pump. Cherry Burrow recommends changing the oil at least every 500 operating hours. The bearings must be greased at least every 250 operating hours. If the pump is installed where moisture and condensation are heavy, lubrication should be made more frequently. Excess grease will accumulate in the bearing housing, can be removed through the lower cleanout hole fitted with the plastic threaded plug. Before working on your Universal 2, disconnect and lock out all power. In addition, drain product from the pump prior to disconnecting piping. If isolation valves are in use, close them and disconnect the inlet and discharge lines. At all times, keep your fingers out of the pump ports. Remove the cover nuts. If your Universal 2 is equipped with optional 3-wing cover nuts, use a soft hammer to loosen them. Metal hammers will damage pump parts. The wing nuts are also fitted for an Allen wrench. Next, remove the cover. If it's stuck, loosen it with a soft hammer, but don't use screwdrivers or other hard objects. When the cover is loose, remove it from the body studs. Be sure you have adequate support for the cover, especially on the larger units. Place the cover on a rubber mat or inside up on the floor or bench. This will help avoid nicks and scratches on the sealing surface. Use a rotor nut wrench or socket to locate the rotors perpendicular to each other. The rotor timing should now be checked. Clearances on both sides, wingtip to wingtip, must visually be equal. Remove the rotor retaining nut of the horizontally oriented rotor. It's a good practice to avoid using a torque wrench for this. You might torque it out of calibration. Use a regular wrench or breaker bar. Lock the rotors in place with a nylon or hardwood dowel so you won't damage these parts. Each rotor nut has a Belleville washer and 2 O-rings. Remove this horizontally oriented rotor. Remove the remaining rotor retaining nut with the wrench, again locking the rotor in place with the dowel. Remove the rotor. The rotors are sealed off so they shouldn't hang up, but if they do, here are 3 handy ways to unstick them. Try prying with wood or plastic dowels. If this is unsuccessful, back out the body retaining cap screws and tap the body forward with a soft hammer. Then just tap the body back and remove the rotors by hand, or by prying with wood or plastic dowels. Although it's rarely needed, a gear puller will help you remove rotors that resist other methods. The puller should contact the rotor in these 2 places. Use a mill file to remove any raised areas made by the puller. After removal, place the rotors on a rubber mat or place the rotors hub down to avoid damage to the rotor wings and front rotor hub outside diameter. Remove and discard the rotor hub O-ring and rotor nut O-rings. If the body retaining cap screws have not been removed yet, remove them now. Remove the pump body by pulling it straight off the body studs. Use a soft hammer and tap on the ports if the body is stuck. Use care to take off the body straight out so you won't damage the seals. Again, place the body on a rubber mat with the mechanical seals facing up. Be careful with mechanical seals and avoid dropping them. Check the rotor wings for indications of metal-to-metal contact. If this condition exists, they may need to be buffed or replaced. Generally, this contact is caused by a twisted shaft, by loose, worn, or mistimed gears, or by loose rotor nuts. Also, check for stress cracks on the rotor wings, which can be caused by excessive discharge pressures. Inspect the keys and keyways of the rotors and shafts for wear. Worn keys should be replaced. Rotors and shafts with worn keyways should also be replaced. This wear can be avoided if rotor nuts are torqued properly. Check the rotor end that locks against the shaft shoulder for wear, as well as the shaft shoulder itself. If this area is worn, a common cause may be extended running with a loose rotor retaining nut or repeatedly slamming the rotor in place on reassembly. If worn, the rotor should be replaced and the shaft should be re-shimmed to maintain the proper back face clearance. Remove the cleanout plug and inspect for excessive or contaminated grease. Bearing condition should be checked whenever the fluid end of the pump is disassembled. If you can detect movement of either shaft at the interface of the shaft and the grease seal, the bearings are failing and should be replaced. You can detect movement by hand loading the rotor end of the shaft to approximately 30 pounds of force. Bearings fail from lack of lubricant, high overload, or water or product contamination. You may have to reconsider your lubrication schedule or look for a means to reduce the hydraulic loads. Excessively leaking seals can lead to the bearings being contaminated by product. Bearings also may fail from over-greasing if excessive grease is not removed at the cleanout holes. If you can feel any free movement when you rotate either shaft without transmitting motion to the other shaft, it's an indication of excessive gear backlash. As the wear on the gears is at 180 degrees, redo the backlash check 2 times at 60-degree intervals. Generally, the cause for excessive backlash is loose or worn gears. Also, check for any axial movement of the shafts, looseness forward and backward. Inspect the mating surfaces on the fluid end and the gear case for paint, rust, raised nicks, and other potential interference with a proper alignment. Clean or remove with a mill file if necessary. Any interference will affect the back face rotor clearances. Similarly, you should clean and inspect all fluid head parts. Mechanical seals are standard with the Universal 2 series pumps. The single mechanical seal consists of 5 components: inner seal O-ring, shaft O-ring, seal seat, inner seal, and wave spring. Handle all seal components carefully. Remove the seals from the body, clean, and inspect them. Do not reuse a seal if the seal face is scratched, chipped, or cracked. Remove the inner seal O-ring and discard. If needed, use the convenient O-ring removal tool that came with your pump. Check with your local distributor about seal repair programs available on hard face seals. Remove the seal seats and the shaft O-rings. Use even pressure on both sides so that you won't crack the seats. The shaft O-ring should be replaced and the seats cleaned and inspected thoroughly. Do not reuse the seal seats if they're cracked, chipped, scratched, or grooved. In a typical repair, such as this one, when the faces are not damaged, they are not replaced. Depending on which seal arrangement your pump has, some color transfer between seal faces is normal. When you follow the procedures we've just covered, your Universal 2 series pumps will provide long, trouble-free service.